Something is happening right now in the Sunda Strait that most of the world hasn't noticed yet. And if you only catch the tail end of it, you're going to miss why scientists who study this exact stretch of ocean are watching it as closely as they possibly can. A small volcanic island sitting between Java and Sumatra has been erupting on and off for over a week now. And the mountain doing it isn't just any volcano. It's Anak Krakatau, the child of Krakatoa, the volcano that quite literally grew back out of the wreckage of one of the deadliest eruptions in recorded human history. Stay with me, because by the end of this, you'll understand exactly why Indonesian authorities have already raised the alert level on this mountain twice in the last 2 weeks, and exactly what they're bracing for next. Let's start with what's actually documented, because the details here matter more than the drama. On July 2nd, at 2:05 in the afternoon local time, Anak Krakatau erupted, sending a dense gray to black ash column roughly 200 meters into the sky, drifting northwest across the strait. At 14:05 on 2nd July, an eruption generated a gray to black ash plume that rose 200 millers and drifted NW. Within about 90 minutes, Indonesia's geological agency made a call that tells you exactly how seriously they were taking it. They raised the volcano's alert status from level 2, waspada, or on guard, up to level 3, siaga, alert, the second highest tier on their 4-level scale. Indonesia's geological agency raised Anak Krakatau alert from level 2, waspada, to level 3, siaga, at 16:30 WIB. Alongside that, they drew a 3-kilometer exclusion zone around the active crater and told residents, fishermen, tourists, and climbers to stay out of it entirely. And this wasn't a one-off spike that faded by the next morning. As of the most recent monitoring reports, the eruption has continued nearly every day since July the 2nd through at least July 9th, with the volcano recorded erupting again late on the night of the 7th into the 8th, and again that same evening, each time registering clearly on seismographs, even when the ash plume itself couldn't be visually confirmed in the dark. The eruption continued at Krakatau on 9th of July 2026, local. The alert level remained at level 3, standby. By the count kept through Indonesia's national monitoring system, Anak Krakatau alone has now erupted at least 7 separate times. So far this year, Anak Krakatau has erupted 7 times this year so far. Here's the detail that separates a genuinely significant escalation from routine background noise. And it's the same detail volcanologists watching any restless volcano look for first: color. A white, billowy plume is mostly steam and water vapor, a volcanic system doing what it does on an ordinary quiet day. It's the mountain breathing. But when that plume shifts to gray, or gray to black, the story changes completely, because gray means the volcano isn't just venting gas anymore. It means solid, fragmented rock is being carried up and out of the crater along with it. And rock doesn't fracture itself for no reason. For fresh material to be entering that plume, magma has to be sitting close enough to the surface to be breaking that rock apart as it forces its way up. Across the past 2 weeks, observers have recorded exactly that shift back and forth. White to gray and white to brown plumes reaching up to 200 meters during the first and days of July, dropping briefly to all white and 150 meters mid-month, then swinging back to darker, ash-laden emissions as the eruptions continued. White to gray or white to brown ash plumes rose as high as 200 malers during 3 to 4 July. Only white plumes were visible during 5 to 6 July, rising as high as 150 malers. That kind of back and forth isn't the volcano settling down. It's the volcano actively working through cycles of pressure release. And the plume alone isn't the whole picture. The ground itself has been telling its own story for weeks now. Indonesia's geological agency reported that in the roughly 2.5 weeks leading up to the July 2nd escalation, the mountain generated an extraordinary amount of seismic activity. 740 emission earthquakes, 520 hybrid earthquakes, 247 low-frequency earthquakes, 24 harmonic tremors, and 16 episodes of continuous tremor. The volcano generated 740 emission earthquakes, 24 harmonic tremors, 247 low-frequency earthquakes, 520 hybrid earthquakes, 16 continuous tremors. Those aren't just numbers to memorize. Each type tells scientists something different about what's physically happening underground. Hybrid earthquakes happen when solid rock is fracturing at the same moment magma or superheated gas is forcing its way through cracks near the surface, like something punching through stone under pressure. Low-frequency earthquakes come from an entirely different process. Fluid and gas moving through the volcano's internal plumbing, more like the rumble of something forcing its way through a pipe than the crack of rock splitting. And continuous tremor isn't a series of individual pops at all. It's a sustained, ongoing vibration, the signal that tells scientists the entire system is active over long stretches of time, rather than just twitching occasionally. There's one more piece of data that officials specifically flagged, and it matters as much as the earthquakes themselves. Tiltmeters, instruments that detect subtle swelling or deformation of the ground, recorded a low-scale inflation trend at monitoring stations around the volcano while all of this was happening. Tiltmeter data at the Cross and Lava 93 stations revealed fluctuating patterns with a steady trajectory, while the Tanjung station registered fluctuating patterns showing a low-scale inflationary trend. Inflation means the ground itself is physically rising, even slightly, a sign consistent with pressure building somewhere inside the volcanic body. Combine that with the earthquake swarm and the shifting plume color, and you get exactly the kind of convergence scientists take seriously. Not one single instrument flagging one. Anomaly, but seismographs, tiltmeters, and visual observation all pointing in the same direction at the same time. Indonesian officials themselves described it plainly. The pattern indicates magma dynamics near the surface of the volcano. The surge in shallow volcanic seismic activity indicates magma dynamics near the surface of the Anak Krakatau volcano. To be fair to the science, and to avoid the trap of treating every signal as proof of imminent catastrophe, officials also noted something important. This activity, as of the initial escalation, was not accompanied by a rise in the deeper tectonic volcanic earthquakes that typically signal, a much larger magma body on the move, nor by major deformation tremors. This was not accompanied by an increase in tectonic volcanic earthquakes, volcanic A and volcanic B, or deformation tremors. That distinction matters. Level 3, Siaga, is a real, serious escalation. It is not the top of the scale, and it is not, on its own, a confirmed prediction of a major eruption or a repeat of history's worst-case scenario. Indonesian authorities have been explicit and consistent about this in their public messaging, repeatedly urging coastal communities in Banten and Lampung provinces to remain calm, continue their normal routines, and not believe rumors that this activity will automatically trigger a tsunami. Residents along coastal areas of Banten and Lampung provinces are urged to remain calm, not believe rumors about a Mount Anak Krakatau eruption causing a tsunami. Now here's why this particular mountain earns this level of scrutiny in the first place. When a similar plume on almost any other volcano on Earth would barely register outside the region, Anak Krakatau sits in the Sunda Strait, born directly out of the wreckage of its parent volcano's catastrophic 1883 eruption, one of the most violent volcanic events ever recorded, a blast that destroyed roughly 2/3 of the original island, sent an ash column an estimated 50 miles into the sky, and produced a sound recognized today as one of the loudest ever documented, audible thousands of kilometers away. The death toll from that eruption reached an estimated 36,000 people, and the detail that ties that disaster directly to what's happening today is this. The overwhelming majority of those deaths didn't come from lava, ash, or the explosion itself. They came from tsunamis, some reaching over 40 meters high in nearby bays. In this stretch of ocean, the historical pattern has never really been about fire. It's been about water. That pattern repeated itself far more recently than most people realize. On the night of December 22nd, 2018, an eruption at this same volcano triggered the collapse of roughly 64 hectares of its flank into the sea. An eruption at 2056. WIB triggered the collapse of about 64 Wikihubers of the volcano's flank. That collapse displaced an enormous volume of seawater in the Sunda Strait and sent a tsunami racing outward toward the coastlines of Banten and Lampung. And crucially, scientific studies have identified this specifically as a sector collapse, a landslide-driven tsunami, not one triggered by a tectonic earthquake. Scientific studies identify the event as a sector collapse on Anak Krakatau's southwestern flank, not a tectonic earthquake tsunami. That distinction is the single most important lesson of that night. A tectonic tsunami comes with a warning built into the earth itself. Violent shaking that, however brief, gives coastal communities a chance to run. A volcanic flank collapsed tsunami has no such warning. The water can arrive with little to no significant earthquake behind it at all. And in December 2018, it did exactly that, striking at night during the holiday season along beaches packed with vacationers who had no physical cue at all that anything was wrong until the water was already on them. More than 430 people were killed. Over 14,000 were injured. And on the small islands nearest the volcano's own crater complex, the water surged to heights exceeding 80 meters. Why is this same island still capable of producing that kind of collapse? Because of exactly how it's built. Anak Krakatau is young, geologically speaking, and it has spent the years since the 2018 collapse actively rebuilding itself, stacking a fresh cone made of loose, poorly consolidated volcanic rock directly on top of the scar left by that earlier failure. A structure built from loose, fragmented material piled on a slope that runs from above the waterline straight down into open ocean is inherently more prone to collapse than a mountain carved from solid bedrock. Under the pressure of continued eruptions, rising magma, or an earthquake swarm, that kind of structure can give way. And when it does, the resulting landslide doesn't stop at the shoreline. It plunges underwater and keeps sliding, dragging more material down with it, doing the actual work of violently displacing the ocean in a way that's completely invisible from a boat or a drone hovering above the surface. It's worth being precise about scale here, because a lot of online discussion around this volcano gets it wrong in one of two opposite directions. The 1883 eruption is classified as a 6 on the Volcanic Explosivity Index, officially described as colossal. It is not, contrary to what circulates online, a supervolcano. A true supereruption, an 8 on that same scale, requires ejecting more than 1,000 cubic kilometers of material, an order of magnitude beyond what Krakatoa produced. But here's the point buried inside that correction that actually matters most. The 2018 disaster that killed over 400 people wasn't caused by anything close to a colossal eruption. It came from a comparatively small flank collapse. This volcano's real danger has never required a historically massive blast to be lethal. It only needs to move the water. So, where does an honest assessment land, given everything actually confirmed right now as of this week? The situation sits deliberately between two mistakes. The first is dismissing it, treating a series of 150 to 200 meter ash plumes as background noise not worth mentioning. Given this volcano's documented history twice over, that kind of complacency isn't appropriate. The second mistake is catastrophizing, treating a level 3 alert and a week and a half of intermittent eruptions as proof that an 1883 scale event or an imminent flank collapse is bearing down on the Strait tomorrow. Nothing in the currently published data supports that conclusion either. Indonesian officials have been clear that, so far, this escalation has not come with the additional deep tectonic seismicity or major ground deformation that would typically precede a much larger event. What they have said, consistently, is that the volcano is under intensive, continuous surveillance, seismic networks, tilt meters, thermal cameras, satellite monitoring, specifically so any further escalation gets caught the moment it happens. And that's really the honest place to land this story. Nobody monitoring this mountain right now, not Indonesia's geological agency, not the international volcanologists watching the same seismic feeds, is claiming to know with certainty what happens next. What they can tell you is exactly what would move the needle. Ash columns growing taller and more sustained rather than fluctuating, continuous tremor intensifying, hybrid and low-frequency earthquakes becoming more frequent and more energetic, visible incandescent lava appearing at the crater. RIM, tilt meters showing a sharper inflation trend rather than a slow one, or officials making the call to raise the alert status again. Any one of those would be a meaningful shift. And it's exactly the kind of shift that would likely make headlines the moment it happened. For right now, this week, the practical picture is straightforward. The alert sits at level 3, not the top of the scale. The exclusion zone is 3 kilometers, and it exists for a specific, evidence-based reason. Anyone near that coastline should respect it without exception. The eruptions have been continuing on and off for over a week, producing modest ash columns rather than a single overwhelming event, and an entire national monitoring network is watching this mountain around the clock, specifically because this stretch of water has already proven, in 1883 and again in 2018, exactly what this volcano is capable of doing to the people living along its shores when nobody sees it coming in time. Whether this current stretch of activity settles back down the way most volcanic unrest eventually does, or whether it's the leading edge of something the monitoring stations are about to catch in real time, is genuinely the open question right now. And it's one that won't be answered by speculation. It'll be answered by the next reading off those seismographs, whenever it comes.